Good day, M3. This is Teacher Bean and welcome to another lesson about electricity. For this video, we are going to talk about basic electronics. For more information, you can read your science book, pages 31 to 41. So let's begin first with your ammeter. An ammeter is a device used to measure the electric current in a circuit. So using your circuit diagram, so your ammeter represents the symbol letter A. So this ammeter is used again to measure your current. So in using the ammeter, you have to make sure that you use it in a series circuit. So do not ever use ammeter in a parallel circuit, or else there will be so much current that will flow in your ammeter if you use it in a parallel circuit. Next is we have your voltmeter. So your voltmeter is an instrument used to measure the potential difference between 2 points in an electric circuit. So for our example here, so you can see here the potential difference between resistance from point A going to point B. So do you still remember your EMF or your electromotive force? So your electromotive force is used to measure between 2 points in an electric circuit, especially in your battery. So if you place your voltmeter here, so you are measuring your EMF. So using the picture here, so this is your voltmeter. So it is placed between the 2 points of your bulb. So it measures your potential difference. If your voltmeter is placed between 2 points of your battery, so it is measuring your EMF. Also, an important reminder, a voltmeter should be placed in a parallel circuit. To check your understanding about ammeter and voltmeter, so I want you to pause this video and you look at the diagram on which number do you think ammeter and voltmeter are properly placed. Okay, so the answer is number 4. Very good. So if you look at number 1, ammeter is in parallel circuit, so this one is wrong. If you look at your voltmeter here, so it's in parallel. However, if you look at your ammeter, it is in parallel circuit, which is wrong. For number 2, ammeter is correctly placed in series circuit. However, your voltmeter is in place of your series circuit. So the correct answer is number 4 because ammeter is in series and then your voltmeter is in parallel. The next electronic circuit is resistor. Resistor. So a resistor determines the amount of current that flows in the circuit. So in short, your resistor is used to control how much current should flow in your circuit. So I want you to remember that when there is high resistance, so little current will flow. So I want you to remember also your Ohm's law, your VIR. So increased current, less resistance. Increased resistance, less current. So speaking of your resistors, so they are too small to print numbers on them. That's why a colored code system is used to indicate the value of resistance. So I wanted to look at the picture here. So you have your different bands. So first band, second band, third band, and fourth band. Other resistors, they have 3 bands and others have like 5 bands or 6 bands. So for example, we will be using your 4 bands here. So each band has a meaning. So band 1 and band 2, they are your digits, meaning they are just your numbers, your whole numbers. Your band 3 here is your multiplier. And then your fourth band here is the tolerance. So if you talk about tolerance, meaning this is like the minimum and the maximum amount, the resistor can hold or control your current. So your multiplier, so the word itself multiply, so it will multiply the number. And then you have here your first band and second band as your digits. So if you're using like 5 bands or 6 bands, so the last 2 lines, like this one, tolerance, and then the multiplier is consistent, so the third and the fourth will become another digit. So here's another example of your 5-band code. So what I've told you. So the last 2 lines they are still the same. So the last line is your tolerance, and then the second to the last line is your multiplier. So looking at this diagram, so you can find this table in your book, so no need to copy. So you have here a 4-band resistor. So this is your first band, second band, third band, and fourth band. So using the table, we are going to analyze the value of each line. So the first digit is red. So in your first band, so this is your first band, so you're going to look at the first column. So the first band states it's 2, right? Then you look at the second band, which is your this one. So this is your another number 2. So you have 2, 2 here. And the third band is your multiplier. So you're going to look at the multiplier here, not the third band, because we are using 4 bands. So in your multiplier, your number 3. So we are looking for the black color. So it has a resistance of 1 ohms. So using the two numbers here, the 2, 2, that's 22 actually. Multiply it by 1 and you will get 22. So to know what is the minimum and the maximum, so you're going to look at the last band, which is your color gold. So your gold here, so it has a tolerance of 5%. So that means if you want to know the resistance or the tolerance of this resistor, so you just have to multiply 22 times 0.05. Again, 22 times 0.05, because 5% is 0.05. So you will get a tolerance of 1.1. So that means this resistor can hold the maximum resistance is 23.1. 23.1. Because the resistance here is 22.1. So the tolerance is 1.1, right? So 1.1. So the maximum is 23.1. And if you talk about your minimum, so you just simply do the reverse. So you have your 22.1 minus 1.1. So that will be 21. Okay. So again, so this resistor can hold current between 21 ohms to 23.1 ohms. So here's another example of your resistors. So you have here your 4-band code and then your 5-band code. So I want you to pause this video and try to understand and digest the meaning of each code. So again, so also at the end, so you have to consider the maximum and the minimum using the tolerance here. So this K here, it means 1,000. So this means 47,000 and this one is 470,000. This number here, 10 to the power of 3. So if you remember about your exponent, so 10 to the power of 3, that is your 1,000. So if you look at it here, so this is your multiplier. So the color of your multiplier here is color orange. So if you look at it here, so 1K or 10 to the power of 3. Next is we have your variable resistor. Variable resistor. So actually there are two here. So we have your rheostat and your potentiometer. So for your rheostat, say it is used to adjust the current, like in your volume adjustment and light brightness adjustment. So I want you to look at the symbol of your variable resistor. Next is we have your potentiometer. So it is used to adjust the current flow just like your rheostat. However, it has 3 terminals here. Okay, so this is now the symbol of your potentiometer. Next, we have another type of your resistor, which is your light dependent resistor or your LDR. So it is a special kind of resistor because it is sensitive to light. So I think you have noticed this one. So at home, if you have like a night lamp, so sometimes if the room is dark, so it will automatically on. And then if it is bright, then it will automatically shut down. So this LDR is sensitive to light. So if you look at the track, so it is a wavy track. So here's the rules. As more light falls onto the surface, so the resistance decreases. That's why light is made. So your LDR have a very high resistance. So as soon as light shines, so the resistance drops immediately. So usually your LDR is paired with your LED. Next is we have your thermistor. So your thermistor, so it is a resistor whose resistance depends on temperature. So in the previous video, so your LDR, it is dependent on the light, right? So for your thermistor, it is dependent on temperature. So I want you to look at the symbol of your thermistor. So your thermistors actually, it has two types. So your NTC thermistors. So the rule for here is that as temperature increases, so the resistance decreases. So it will allow the current to pass through. So they are very common in oven, air conditioner, and fire detector. The second type of your thermistor is your PTC. So the rule is that as temperature increases, so resistance increases. That is to block your current. So this is to prevent the overflowing of current in your circuit. Next is we have your capacitor. So a capacitor is used to store electrical energy. So it allows to keep the voltage at a certain level. So if ever you need a high voltage surge or instant high voltage requirements, so such as your camera flashing, so your capacitor is better to solve this demand of your high voltage. So in your capacitor, so I want you to look at the symbol na. So it may look like a battery, right? Or I mean it may look like a cell, but the two lines here are of the same height. So in your battery or your cell, remember that one line is longer and the one line is shorter. So in your capacitor, both lines are of the same height. So please take note, M3. Next is you have your LED or your light emitting diode. So your diode, basically it is used to provide a one-way flow of your current. So your LEDs emit, or shall we say give off light. So as what I've said, so diodes allow current to flow in one direction. So using your conventional flow, so always remember that your electricity flows from positive to negative. So your anode here, that's another word for your positive, and your cathode here, that is another word for your negative. So just in case, so if you want to use your LED, so LEDs are very cheap. So that's why you have to remind yourself that using this one, so you need to have a resistor if you're using a voltage of more than 3 volts, or else your LED will be damaged. So if you look at closely your LED, so it has two legs. So the longer leg represents your positive terminal. Your shorter leg represents your negative terminal or your cathode terminal. And then just in case, if you cut this, the legs, so if you cut them, so they will be of the same height, right? So how will you know which one is cathode and which one is anode? So just look at the flat side of your LED. So this flat side here represents your cathode or your negative terminal. Next, we have your transistors. So transistors have two functions actually. So it can be used as a switch, so meaning it can turn off or turn on. And then it is used to amplify a signal. So amplify meaning to get the signal very stronger. So can you just imagine this one? So a transistor, very tiny, but it works like magic because your small current using transistor, so it can make it a big current. So your transistors, they have three legs also. So each leg has meaning. So your E here as your emitter, so it is the negative terminal. So B here, or your base, is your it activates the transistor, so meaning it should be connected to another source for your transistor to work. And then we have your letter C, or your collector, which is your positive terminal. So there are two types of resistors here. You have your NPN, which is the most commonly used because it requires a minimum amount of 0.7 volts to activate your resistor. So if you want the current to flow from your collector to your emitter, So your base here should be supplied with a minimum of 0.7 volt. That's why NPN is commonly used transistor. However, in your PNP, so it's not commonly used because it's the opposite for NPN, because it requires a minimum difference of, I think, 0.7 volt as well. So most of the manufacturers, so they go with the minimum supply of 0.7, especially in the case of your NPN. So these transistors are used in radio amplifiers, alarm circuit, and TV sets. So let's try to connect some of the circuits here. So we have here a picture of your diode being connected in your circuit. So we have here your battery, you have here your diode, and we also have here your light bulb. So basically, so if you are to connect your diode, so you have to be particular which side is the positive and which one is the negative, right? So as you look at here the picture, so this arrow here is pointing to where the direction is, or to where the current is flowing. So just look at the arrow, right? So as we all know, current flows from positive to negative, right? So the arrow will always point from positive to negative. So this setup here will cause the light bulb to light up, because this side here, this one is positive, negative, positive, negative, positive, negative, right? So if the electric current will flow from this direction, because from positive going to negative, so that means, so your positive will simply go to your diode, because your diode receives the electrons coming from your positive terminal of your battery, and then will exit in your negative terminal of your diode, right? Going to your light bulb, then going back to your battery. However, in this scenario, so the light bulb will not work. Why? Because if this is your positive terminal of your battery, so as the current will flow, however, the current cannot flow here because it is facing the negative side. So meaning there will be no current flowing in this diagram. Okay, so that's why if you are going to use a diode, so you have to identify the correct position of each terminal. So positive terminal should always face the positive terminal of your diode. Otherwise, if the positive terminal of your battery is facing the negative terminal of your diode, then your circuit will not work. So here is another example. This time we are using your cell. We have here your LED, and we have also here your resistor, and we also have here your transmitter. And then remember that in your transmitter, so this one is your C here, your collector. This one is your emitter, right? And then this one is your B here is your base. So in this circuit, so the current is not yet flowing because the 0.7 volt, the minimum requirement, is not yet finished. I mean, not yet present. However, if this voltage here starts to work, and it will flow now to your base. So your base here is like a switch here, wherein it will allow us now to, or it will allow your current to flow now from your current and emitter. So basically, so once it's open, so current will flow, and then it can now use the energy stored in your 9-volt battery to allow the LED to turn on. Okay, so again, so without the minimum voltage requirement to turn on your base, no current will flow. So meaning LED will be off. However, if there will be the 0.7 volt movement going to your base, so it will connect this collector and your emitter. So therefore, your LED will turn on. So as for your homework, so I want you to answer pages 42 and 43. That's all for the lesson for this video. So don't forget to do your homework and send it to the Google Classroom. And once again, thank you for watching and have a nice day.